In this example problem, we're given a wave function. So we have y as a function of x of t equals 3.4 millimeters times the cosine of 12 radians per meter times x minus 350 radians per second times time. So our first question asks us what's the amplitude of the wave. The amplitude of the wave is always the number in front of the cosine. So that's going to be 3.4 millimeters or 0.0034 meters. In the second part, we're asked what the frequency of the wave is. So the first term inside of the cosine function is the wave number, and the second term inside of the wave function is going to be the angular frequency. So since we have the angular frequency, we know angular frequency equals frequency times 2 pi, so we can take the angular frequency divided by 2 pi to get a frequency of 55.7 hertz. The second thing, we want to know what the wavelength of the wave is. Now I said the first term inside of the cosine was the wave number, and we know the wave number is 2 pi divided by the wavelength. So we can find that the wavelength is equal to 0.52 meters. Now we know what the speed of the wave is. Well, the speed of the wave is equal to frequency times wavelength. So we have our frequency and we have our wavelength already. So we can get a velocity of 29 meters per second. Now we want to know what the direction of the wave is. And direction of the wave is told to us by the subtraction or addition inside of the cosine term. Since it's subtraction, that tells us the wave is propagating in the positive x direction.